Hello everyone. So my name is Jackie. So it's my pleasure to talk to you about a subject about a workflow language for guarded transactions upon information systems. So in this paper, we'll actually guide you through a workflow language, and then I will actually talk about different semantic views for the language in order to achieve some goal. I'll actually tell you what exactly the goal is in the talk. So first of all, the application domain of my research, of our research, is that of information systems, where our main concern is to manage, provide, and store the data. And the emphasis is upon data. And usually what we really care is to express the semantics of data in terms of associations and constraints. And this semantics must be always maintained. And if the semantics of the data is actually violated, then there are actually two possibilities. One, queries to the system may not work anymore. Or you might have some results from your queries, but the result that you got from your queries may not mean what we think they mean. So both possibilities are not good. So we better make sure the semantics of the data are always maintained. So this is why usually the operations that we perform upon the information systems are simple transformations. And because they are simple, developers for the information system, they can actually specify the operations precisely. And because they can specify the operations precisely, we can characterize when exactly we may call these operations, such that the semantics of the data is never violated. And now, let's just give you one example. Let's say we have a hotel booking system, and what we are storing are two attributes. The first attribute is reservations, and that represents the number, the set of unconfirmed bookings of a hotel. And the other attribute we have is allocations, which will store the set of unconfirmed bookings. So of course, the obvious validity constraint would be the dates to be reserved should never conflict with those that have been allocated already. It's an obvious constraint. However, we have to really constrain this requirement upon our systems and make sure no operation should ever violate this constraint. Now, every time we specify an operation, we have to make sure there are two things that are specified. The first one is called a postcondition, which will characterize precisely what's the intent of your operation. And the second thing you have to specify for the operation is called the preconditions, which means under what circumstances can your operations be called, such that after you apply the intent of your postcondition, the semantics of your data is still maintained. So these are the two things you want to specify for your operation. And usually, we will typically actually implement our postcondition as atomic transactions. So it's actually an atomic units for your updates. And for the precondition, we'll implement it as a guarded condition, which means every time, if it is not safe to call your operation, we should really block the operation, so make it unavailable for you to call. So preconditions and postconditions are the specification for our operations. Now, however, sometimes we may not actually want to perform our updates always as an atomic unit, because first, we might want to collect some inputs along the way. And second, the update itself might last for a long time. And it is not practical to actually restrict the data store when the updates are being performed. It is simply not fair to other workflows or other processes. So instead, what we're going to do is to run and specify workflows as patterns of operations that will actually combine transactions together. And what we really want to make sure is we always allow operations from different workflows to be arbitrarily interleaved. So that's the main advantage we gain by running the workflows rather than atomic transactions. And now, here comes the questions. If we allow the interference for our workflows, it raises a very important question about whether the workflows can successfully complete. So let's say on the one hand, if you run our set of workflows in parallel together, you can be pretty sure in any intermediate stage, your data integrity can be maintained because individual transactions will do. However, on the other hand, because we allow operations to be arbitrarily interleaved, it might be the case that somehow you have modified your system state such that the guarded condition for the next operation is falsified. So it will be blocked. So you will actually never be able to complete the workflow again unless you actually got some magic operation that will fix the system state so you can complete the workflow again. So that's really about data integrity and completion. Data integrity is for sure, is ensured, but completion is not ensured. And this is exactly the main concern of this paper. Let's just go over one motivating scenario. Let's say we have two simple workflows for hotel booking system. So the first workflow, make booking, is actually to make a new booking for an input date. The second workflow, cancel or change booking, is actually to deallocate an existing booking and then to add another new booking. So let's say we happen to have two requests for the same dates for the two workflows, and there's only one room available right now for that date. So whichever workflow that attempts to commit for the booking in a later time will actually get stuck indefinitely until there's another room available. So you can actually see the issue. In a scenario like this is exactly the concern of this paper. We actually want to characterize under what circumstances can we actually run a parallel combination of workflows together without blocking any of the workflow in the middle. We don't want to let the user to actually say, I commit my room booking already. However, maybe at some point later, the system will tell me, oh, sorry, maybe the booking is not available anymore. We don't want this to happen. This is certainly unacceptable. Right, so this is exactly the objective, as I just said. We will actually try to formalize this objective by defining a formal language and its formal semantics, and let you know what should be mathematical construct for this objective.